Today we are going to talk about squares and square roots. Squaring a number is raising that number to a power of 2, an exponent of 2. An exponent is that little raised number next to a number. So if you look at this example here, it has 4 squared. That little 2 is called an exponent, and it means 4 times 4, and 4 times 4 is 16. We read that as 4 squared, so 4 squared is equal to 16. When you are squaring a number and it has a negative value, you have to be very careful to note whether or not the negative sign is inside the parentheses. If the negative sign is inside the parentheses, it is included in the squaring. So for instance, if you look at this first example, negative 2 in parentheses squared. Well, that means negative 2 times a negative 2. So negative times a negative is a positive. So the answer to that would be positive 4. Negative 3, where the negative sign is in parentheses squared, means negative 3 times a negative 3. And again, a negative times a negative is a positive, so negative 3 squared is positive 9. Negative 4 squared, where the negative sign is in the parentheses, means negative 4 times negative 4, which would give you a positive 16. Now, the trick comes in when the negative sign is not in the parentheses. Remember, a negative sign means the opposite. So whenever you have this first one, negative 2 squared, where it's not in parentheses, it means the opposite of 2 squared, or the opposite of, figure out what 2 squared is, that's 4. So negative 2, not in parentheses with a negative sign squared, is actually a negative 4. Negative 3 squared, again, first you have to square the 3, and then you put the negative sign in front, and so that would be negative 9. And negative 4 squared, no parentheses, is negative 16. So try to remember that if the negative sign is inside the parentheses, then it is included in the squaring. If it is not in the parentheses, that means you put a negative sign in front of your answer. Okay. Now what we're going to do is we're going to go the opposite or the inverse direction, and we're going to look at taking the square root. So if squaring a number means taking a number and multiplying it by itself, then taking the square root, which is the inverse or opposite is the opposite of squaring the number. And so what we want to do is go backwards, and if I say to you, what's the square root of 16? I want to go backwards and figure out what number times itself gave me 16. So again, square root is the inverse or opposite of squaring. So when you take the square root of a number, technically it could be 2 different answers. The square root of 16 could be both 4 or negative 4, because a 4 squared is 16, but also a negative 4, where the negative sign is in the parentheses, if that is squared, it is 16. Because 4 times 4 is 16, and negative 4 times negative 4 is also 16. So technically, when you take the square root of a number, you actually have 2 different answers. Now, most of the time when you take the square root of a number, we're just going to focus on the positive square root, and that is called the principal square root. So when you see the square root sign, the solution is usually that positive square root for most practical purposes. But if you're asked to give 2 answers, you would say the positive and negative of that number. Now, the number 16 is called a perfect square because its square root is a whole number. And what I'd like you to do now is I would like you to generate a list of perfect squares. So if you would please complete the tables at the bottom of the page and complete all the squares, and then find for me all of this, what all the square roots are that would give us the numbers below in the table. Go ahead and hit pause and hit play when you are ready. All right, your table should look like this. And all the numbers in front of you that you see across the first row, second row, I should say, in the table at the top here. All of these numbers here, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225, those are all called perfect squares, because if you are asked to find the square root of them, like in this second table down here, they come out to be a whole number. Those perfect square numbers are very important as you move forward in algebra. We use them a lot. And so you want to try to commit those to memory. You want to have those memorized. So most of them you probably have memorized already. I tend to find that learners get tricked up on 13 squared and 14 squared. So if you kind of look at the pattern, 13 squared is 169, and 14 squared, reverse the 69 and make it 196. Maybe that's a little trick that might help you. 15 squared, 225. But you want to try to commit all of those to memory. One more thing that I want to point out about all of those perfect squares is that you can actually build a square with that number of squares that you have. So, for instance, I could build, if I have the number 9 here, I could build a square that is a 3 by 3 square. The length of each side would be 3. If I have 64 squares, I could actually build a square where each side would be 8. 8 because 8 times 8 is 64. And that was something that you might have seen doing that Minecraft activity. So again, perfect squares are numbers that if you had that many blocks, you could actually build a square out of those number of blocks. All right, let's practice with some calculations involving squares and square roots. So problem number 1. Actually, why don't you go ahead and hit pause, try 1 through 6, and then hit play when you are ready. All right, problem number 1, you want to be careful. The negative sign is in the parentheses. And so what you want to make sure that you're doing then on this one is you're taking -7 times -7. The negative times the negative is a positive, and so the answer to problem number 1 that you should have gotten is 49. Problem number 2, when you see a fraction squared, just square the top and square the bottom, because this means 2/3 times 2/3. So take 2 times 2, or 2 squared, which is 4, and then across the bottom you would do 3 times 3, or 3 squared, which is 9. So the answer is 4/9. Problem number 3, notice that the negative sign is not in the parentheses. So the first thing you do is you square the 9, and that gives you 81, and then you put the negative sign in front. So the final answer is -81. Now let's look at square root. Number 4, the negative sign is in front, and we're just going to find the square root of 196. That is one that you should memorize. The square root of 196 is 14, and then just bring that negative sign down and put it in front. And so this becomes -14. Problem number 5, you should recognize that we have the square root of 0.81. Now, 81, we know the square root of that's 9, so there probably is a decimal number that when I multiply it by itself would give me that 0.81. And the answer is 0.9. Remember, when you multiply numbers that are decimals, you would add up the number of decimal places you have, and that's how many decimals you have in your answer. So 0.9 times 0.9, I have 2 decimal places. I have 2 in my answer. Problem number 6, again with a fraction, when you have the square root of a whole fraction, just go ahead and take the square root of the top and the square root of the bottom and simplify it that way. And so the square root of 9 is 3, the square root of 16 is 4, and so the answer is 3/4. All right, now try these problems, number 7 through 12. Hit pause and then hit play when you are ready. Okay, so these are a little bit trickier because you might not have known what to do when you see this number in front of a square root sign. So just like when you see a number in front of an x, we know that it is implied that they are multiplied together. So the same thing with the square root. If you have a number in front of a square root, it's implied that they are multiplied together. So problem number 7, 2 times the square root of 64 is 2 times whatever the square root of 64 is, which is 8, and 2 times 8 gives us 16. So a number in front of a square root means multiplication. Problem number 8, what you had to do first was just simplify the square root of 121, which is 11, and then you have 5 plus 11, and the answer is 16. Number 9 involves both of those skills. You're going to take -3 times whatever the square root of 225 is, that was 15, and after you do that, you'll add 10. Remember to follow the order of operations. So -3 times 15 is a -45, and a -45 plus 10 will give you a -35. Problem number 10, the square root of 144 is 12, the square root of 36 is 6, take 12 minus 6, and your final answer is 6. Problem number 11. Again, a number in front of a square root means we're multiplying. So we're taking 15 times the square root of 16, which is 15 times 4. And if you multiply 15 times 4, you get 60. And lastly, problem number 12. Again, the negative sign in front of the square root just stays. The square root of 81 is 9. And if you have negative 9 plus 20, the final answer there would be 11. Now let's try just a couple more application problems. Problem number 13 says a group of 225 students need to be arranged in a square formation for a halftime performance show. How many students should be lined up in each row? So if you think about a square and you want to make it, if you're lining up students in rows, if it's square, there has to be an equal number of students going across this way and going up and down this way. Now, if it's 225 students that I want to fill in this spot right here, basically that's an area problem. I'm trying to figure out what number of rows and number of rows this way, when I multiply them together, is going to give me 225. So when you're trying to figure out what number times itself gives you 225, that means we're finding the square root of 225. And that's one that we know the answer is 15. Problem number 14 tells you that you have an area of a square. It's 144 square feet. If you remember, a square has two equal sides, so the area is just the side squared. They want you to find the perimeter of the room. So to find the perimeter, we need to know the length of each side. Remember, perimeter means we're going to add up the distance going all the way around the outside of the square. So I've got to figure out, if the area is 144, what number squared gives me 144. So to find that number, I take the square root of 144, because that is the opposite or inverse of squaring. The square root of 144 is 12. So every side has a length of 12. So if I want to find the perimeter now, what I need to do is add up all the sides, or I could take that 12 and multiply it by 4, because all the sides are the same. So my answer is that the perimeter would be 48 feet. So that is a review of squares and square roots.